everyone, welcome back to Conversations in Future Air Mobility. I have the great pleasure to be here with Rod Williams, who's the Chief Commercial Officer at Universal Hydrogen, one of the leaders in the hydrogen aviation space. Thanks so much for joining us.
You're welcome, Robin. Good to see you and glad to be here.
Yeah, let's start talking a bit about what you guys are doing. So on the one hand, hydrogen infrastructure was one of those things you identified as a challenge and you're building a solution around it. On the other one, you're building a powertrain for an aircraft to really enable that industry. Tell us more, what is behind that strategy and what are the things you're concretely doing?
Yeah, so the infrastructure problem with hydrogen has been the main obstacle for the commercialization of hydrogen-powered aircraft. Hydrogen-powered aircraft have been demonstrated going as far back as the 1970s. So in our view, the technology to create a hydrogen-powered aircraft has never been the issue. The issue has been the infrastructure and the logistics required to ultimately connect the point of production of hydrogen to the point of consumption, which is the aircraft. And if you were to take a traditional route to build that infrastructure out with on-airport storage and tarmac pipelines, specialized tanker trucks and all that, it would be a massive amount of investment. So really the key unlocking feature that Universal Hydrogen has come up with is the modular solution of delivering hydrogen. So we deliver hydrogen to the aircraft using modules that are filled with hydrogen at the production site, and then we use a standard intermodal shipping system to transport the hydrogen modules to the airport and ultimately onto the aircraft. So you're really utilizing a transportation system which has trillions of dollars invested in it and leveraging all of that investment to transport the hydrogen anywhere in the world, and that's the other unique feature of the solution is that it's highly scalable. So you can start a new service at a new airport simply by shipping a truck with hydrogen modules on it to that location.
Great. I mean, one of the questions that comes with that, you have a carbon impact by moving those containers and by using that transportation system you're talking about. However, it still sounds like overall this is still less carbon intensive than traditional systems. Is that true?
Sure. It's a true zero solution as opposed to a net zero solution, which something like SAF is, and SAF isn't even a 100% net zero solution. So from an aviation perspective, absolutely, it's fundamentally different and better than using any other solution. So. And eventually trucking will get there too, and that's moving actually very rapidly as well too. We'll get to a point where the trucking network and trucking transportation system will be running on true zero solutions as well too.
Got it. So, and then you are also building an aircraft powertrain to kind of jumpstart that industry. Tell us a bit about that.
Yeah, so again, the technology for creating a hydrogen-powered aircraft has been demonstrated in the past. But when we came up with the infrastructure solution to ultimately unlock the ability for those hydrogen-powered aircraft to fly using our modular solution, we also wanted to move forward with what we called a permissionless business model, meaning we didn't want to rely or wait on anyone else to create that aircraft product. So we said, let's go and create that aircraft product ourselves. So in order to do that, we're developing our own hydrogen fuel cell powertrain solution. We've gone after what we think is the largest aircraft size that is feasible with a hydrogen fuel cell solution, which is basically the 2 megawatt class powertrain. And we've been very successful in the development of that. We've been running an Ironbird powertrain system since February, very successfully. It's a 1 megawatt class powertrain, so half what we'll ultimately have to certify with. But we've demonstrated the complete architecture over the last 6 months and running it ever since February. So that's allowed us to create the SDC solution for both the Dash 8 Series 300 and the HR 72 family of aircraft. So as you say, we can create the demand in the system for hydrogen that ultimately our infrastructure solution provides.
Exciting. So you're the Chief Commercial Officer. You're pitching this to airlines. What do you hear back?
Oh, listen, there's incredible interest in sustainability in general and incredible interest in our solution as well, because there's 2,400 turboprops that are out there, over 300 airlines that operate those aircraft. They all want a sustainable solution. So our pitch, our solution, where we go to them and say, we'll deliver a full solution for you, we'll take your aircraft and retrofit it, and by 2025 we can deliver to you a hydrogen-powered aircraft as well as the logistics solution to deliver hydrogen. They're incredibly enthusiastic.
Excellent. So what time frames are we talking about when we go about, building out this network, building the capability, retrofitting aircraft? When does the average consumer get a chance to fly in a hydrogen-powered aircraft?
2025.
2025.
Yeah, our certification plan has our first STC certified in 2025, and service entry shortly thereafter, of course. And as part of that, and as part of those milestones, we're scheduled to have our first flight of our flight test aircraft before the end of this year. And that'll really mark, in our view, substantial retirement of the technology risk, because we'll have built a powertrain, integrated the full powertrain in the engine nacelle, so all of the fuel cells, the electric motor, all of the balance of plant will be integrated in the nacelle as it will be in the final STC configuration. And we'll have demonstrated that, and we'll have built a bunch of flight hours on that aircraft, and that'll really kickstart our certification process. And that'll also allow us, which we're starting to do now, to move into a more operational phase where we're building out the logistics network. We have agreements with offtake producers right now for hydrogen, and we'll continue to build out that value chain with our launch customers and with the customers that we expect to ramp up with. So this year we'll transition from that technology development and risk retirement to really going full speed ahead on building out the hydrogen value chain.
Excellent. Well, that's exciting. And then your other customers, other than the airlines, are going to be OEMs that are building aircraft to use your energy storage system in the end of the day. How are discussions going there?
Oh, they're going great. We see many opportunities in other aviation verticals outside of the turboprop program. We have a variety of discussions which are quite well advanced that we'll hopefully be announcing shortly. But as one very good example of that, we have an agreement with Deutsche Aircraft to work with them to supply only our capsule and module technology to some of their advanced design Dornier 328 programs that they're working on. So they're developing the aircraft, they're integrating the systems into the aircraft. They're working with not us as a powertrain supplier, but a different powertrain supplier. And we're totally comfortable and happy with that type of relationship where we're supplying our hydrogen module and capsule technology, because that's where we want our business to lie. We don't want to be an aircraft OEM. We're very happy to work with anyone else that happens to bring along their own powertrain, and we'll supply the hydrogen module and logistics solution.
Great. What are, if any, big misconceptions about hydrogen aviation that you would want to clear up? I mean,
yeah, I think the biggest one for me is, which is one that I've learned as I started my journey with the company and in this area, is the technology development, right? A lot of the core technology that we're working with it has existed for a while and is quite well advanced. What we've done is we've taken those core technologies, be it the electric motor or the fuel cells, and we've integrated that, and we brought our own IP on top of that, which is a balance of plant and the control system, to really integrate that. But a lot of the core technology has been advanced enough that we've been able to go quite rapidly in particular building the powertrain that will ultimately bring the aircraft to market. So I think people think that hydrogen-powered aircraft need to be 20 years away, and we don't. We absolutely think that we've got a solid plan that will deliver that much quicker than that kind of time frame.
Excellent. Very well, thank you so much for making the time and having this conversation. All the best of luck as you bring this technology to market, and I really look forward to flying one of your hydrogen aircraft in 5 years then.
Thank you very much, Robin, and we'll hope to see you at our first flight before the end of the year as well, too.
Oh, I look forward to that. Thank you.
Thank you.